Okay guys, we're going to do check your understand on page 355. A large auto dealership keeps track of sales made during each hour of the day. Let X be the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. Okay, so there's a 30% chance they're going to sell no cars, 40% chance one car, and so on in that first hour of business on a Friday. So we're going to compute the mean. Okay, the mean of a random variable is, this is the mean of X. It's also called the expected value. Okay, so how we calculate this, we might see it as the expected value of X. It is basically, it's a weighted average. So you multiply each probability times the number of cars sold and you add them up. Okay, it's just how you calculate your grade when you have weighted grades. So cars sold is 3, you have a 30% chance of that. 1 car, you have a 40% chance. 2 cars, a 20% chance. And 3 cars, a 10% chance. Throw that in the calculator and you get 1.1 cars. Now, if we try to, actually, let's interpret it real quick. In many Fridays, if many Fridays are randomly selected, the typical number of cars sold would be about 1.1 cars. Okay, so that's my interpretation. Now, if we think about our expected value in terms of the graph, let me come over here and just do a quick little graph. Okay, so we'll have 0, 1, 2, and 3, and then our probabilities only need to go up to 4. 1, 2, 3, 4. 0.1, 0.2, 0.3. And again, just as a little aside, 0 is 0.3, 1 is 0.4, 2 is 0.2, and 3 is 0.1. If you think about it, your typical value, your center, would fall off that peak a little bit. So it would be between 1 and 2, and that's exactly, go over here, that's exactly what it was, 1.1 cars, okay? Okay, now let's do the standard deviation, okay? Now, standard deviation, it's the same concept of any standard deviation. It's the typical distance that each data point is from the mean, okay? So we have to sum up each data from the mean and square it, and then we add them up and then we square root. But you have to take into account the probability of each piece of data, okay? So let's do all of these step by step. So I have each X minus the mean. Okay, so I know the mean, each X, I know the mean. Oh, why did I put 5? That's a 1, okay. Let's see, that's negative 1.1, that's a negative 0.1, 0.9, and that's 1.9, okay. So I did my subtraction, each data point from the mean, and then I got to square them. But then I have to take into account each probability, okay? So 0 cars being sold has a probability of 0.3, 1 car, 0.4, and so on, okay? So if I do all these individual calculations, and don't worry about it, we're going to do it in the calculator, and this is the only time you have to do it, but you need to be familiar with it. Put these in the calculator, double check my calculating. If I add all those up, I'll get 0.89, and then I have to take the square root. So my standard deviation is 0.943 cars. So if I interpret this, the number of cars sold on a randomly selected Friday will typically vary by about 0.943 cars, okay? Now if I put my interpretations together, I would say in many Fridays, if many Fridays are randomly selected, the typical number of cars sold will be about 1.1 cars, and that would vary by 0.943 cars. Okay, so there's my combination of my interpretations. Don't stop it yet. Okay, I want to show you how to do this stuff in the calculator. Okay, zoom out a little bit so you can come back up here. Okay, how we're going to do this in the calculator. Now, you need to know the formula for mean. You're going to be expected to do that by hand, and you're going to see that in multiple choice questions, okay? Formula for standard deviation, yeah, you're not going to do that by hand. That's going to be in the calculator. So, how we do this in the calculator, can you see that and that? We go to our lists. You put your random variable in list 1, okay, and you put their corresponding probabilities in list 2. Okay, so there's my number of cars sold, the probability that each one of those cars will be sold. Then I go to stat, calc one variable stats. My list of my random variables in list 1, but the frequency or the probability is in list 2. Okay, so now when I calculate a mean and a standard deviation, it's going to take into account each of the random variables probability. Okay, so there's my mean of 1.1 cars. Can you see that? And there's my standard deviation of 0.943 cars. Okay, there is no sample standard deviation. This is a population standard deviation. Okay, okay, that's it for that. See you next time.